Good morning. Continuing with Chapter 11, that is Mensuration. Today we will solve exercise 11.3, which is based on surface areas and literal surface areas of three solid shapes, that is cube, cuboid, and cylinder. So, exercise number 1. There are two cuboidal boxes as shown in the adjoining figure, which has box requires the lesser amount of material to make. Okay, it is given two cuboidal boxes with the measurement are given, and we have to find out that which box will require less material to make it. So A and B two cuboidal boxes are given. Let us take first box A, where the measurements are given as length equal to 60 centimeter, breadth 40 centimeter, and height 50 centimeter. So total surface area of the cuboid A is equal to, the formula to find out surface area of cuboid is twice LB plus BH plus HL. So we write the formula, that is twice LB plus BH plus HL. Now we insert the values of length, breadth, and height. Yes. So here you can see that length is 60 centimeter. This is our length, this is our breadth, and this is our height. So we have to insert the values accordingly, then only you will get the perfect answer. Don't make mistakes in taking length, breadth, and height. That is equal to 2 times length into breadth. Now here you can see length is 60 centimeter and breadth is 40 centimeter. So we'll write 60 into 40. Then breadth into height. Again breadth is 40 and centimeter and height is 50 centimeter. And then next height into length. Height is 50 centimeter and length is 60 centimeter. So we get twice 60 into 40 plus 40 into 50 plus 50 into 60. Let's solve for that. That is equal to twice into 60 into 40, that is 2400. We can easily do this, 2 zeros as it is, and 6 fours are 2400. Then 40 into 50, that is 4 fives are 20 and 2 zeros back. And then 50 into 60, that is 5 6 are 30 and 2 zeros, that is it. So we get twice 2400 plus 2000 plus 3000, that is equal to 2 into 7400, that is equal to 14,800 centimeter square. So the TSA, total surface area, in short is said as TSA. TSA of a cuboid A is 14,800 centimeter square. Now let's see the another cuboidal box. Here you can see that in this cuboidal box all the three dimensions are having the same measurement. So same measurement, when it can be the three dimensions are the same when we have a square, but actually it is given in the question that we have to count as cuboid. So we will apply the formula of cuboid only here. So total surface area of a cuboid B equal to twice length into breadth plus breadth into height plus height into length. Let's insert the formula, that is everywhere you will get 50, as you know that length, breadth, height all are 50. So we'll get twice 50 into 50, again plus 50 into 50, again we will get plus 50 height and 50 length. So 3 times we will get twice 50 into 50 plus 50 into 50 plus 50 into 50. For the solving we will get equal to twice 2500 plus 2500 plus 2500, that is equal to 2 into 7500, yeah 7500, that is equal to 15,000 centimeter square. Now let's see which cuboidal box is having less surface area, whichever box is having the lesser total surface area, that box will require less material to be to make it. So here when we compare, this is our 14,800 and this is 15,000 centimeters. So you can see that this is less. Area of cuboidal box A is less. So since TSA of cuboid A is less, cuboid A will require lesser material. Next, question number 2. A suitcase which measures 80 cm by 48 cm by 24 cm is to be covered with a tarpaulin cloth. How many meters of tarpaulin of width 96 cm is required to cover 100 such suitcases? Now it is given a suitcase. You can see that 3 dimensions are given. So it is in the cuboid shape. So its length, breadth and height is given. Length is given as 80 centimeter, breadth is given as 48 centimeter and height is given as 24 centimeter. Whenever measurements are given in this multiplication form, always length is first, breadth is second and height is third. Moreover, it is given that this suitcase has to be covered with a tarpaulin cloth, and the tarpaulin cloth, you know that cloth is a plain 2D rectangular shape. So it will have length and breadth. So its width, that is breadth, is given as 96 centimeter. We have to find first the length of the tarpaulin cloth, and then that is for we will find for one suitcase, and then we will multiply by 100. So because we have to find out how much meters of cloth is required for 100 suitcases. So let's solve question number 2. Measure of suitcase is given as 80 centimeter into 48 centimeter into 24 centimeter. Means length is 80 centimeter, breadth is 48 centimeter and height is 24 centimeter. Moreover, width of tarpaulin cloth is given 96 centimeter and number of suitcases is given as 100. As we are not copying the question, dear students, we write the information so it becomes easier for us to solve the given question. Now first let's find the TSA of suitcase. Therefore, total surface area of a suitcase equal to twice LB plus BH plus HL. Inserting the values, we get equal to twice 80 into 48 plus 48 into 24 plus 24 into 80. That is equal to twice 3840 plus 1152 plus 1920. That is equal to 2 into 6912. That is equal to 13,824 centimeter square. This is the TSA of one suitcase. Now also it is given that as we need the whatever is the surface area of the suitcase, that much cloth tarpaulin cloth will need to cover it. Therefore we write area of tarpaulin cloth equal to surface area of suitcase. Now area of tarpaulin cloth is given by length into breadth, because cloth is a 2D rectangular shape. So it is length and breadth. So we write area of tarpaulin cloth is equal to length into breadth, and already we have seen that surface area, you can see above only we have found out surface area of suitcase, that is 13,824. Now already breadth is given in the question itself, that is given as 96 centimeter. So we insert the value of breadth, that is L into 96 equal to 13,824. Solving further, we will get L equal to 13,824 divided by 96. Yes, because we transpose 96 on that side and multiplication becomes division. So L equal to 13,824 upon 96 implies that L equal to 144 centimeter. So for one suitcase, 144 centimeter length of tarpaulin cloth is required. Now as we need for 100 suitcases, therefore required tarpaulin for 100 suitcases equal to 144 into 100, that is equal to 14,400 centimeter. Now this is in centimeter and we have to find the answer in meters. It is asked that you have to find out how meters of cloth. So we convert this into meter, that is we know the relation between meter and centimeter. 1 meter equal to 100 centimeter. So we divide by 100, so we will get meter, that is equal to 14,400 upon 100 meter, that is equal to 144 meter. Such hence 144 meter of cloth, tarpaulin cloth is required to cover 100 suitcases. Next, question number 3. Find the side of a cube whose surface area is 600 centimeter square. Okay, now we are already surface area is given and we have to find out the side of a cube. You know that cube is made up of square and square has only one dimension, that is side or length. So we can easily find out the length from the surface area. So let's solve. Surface area of cube equal to 600 centimeter square is given. Now surface area of cube is 6L square, that is equal to 600. That implies that L square equal to 600 upon 6, that is equal to 100. Here you can cut 6 ones are and 6 hundreds are, so we will get 100. Yes. So L square equal to 100 implies that L equal to under root 100. Now 100 is the square of 10, so we will get L equal to 10 centimeter. Therefore side of cube is 10 meter. It should come centimeter, by mistake it is written meter because it is asked in centimeter only. So the length of side of cube is 10 centimeter. Please students, do this correction while copying. This should come 10 centimeter. Here it is proper, but in writing the answer it is by mistake written meter. Next, question number 4. Ruxar painted the outside of the cabinet of measurement 1 meter by 2 meter into 1.5 meter. How much surface area did she cover if she painted all except bottom of the cabinet? Now let's see the cabinet. Here you can see the cabinet. Its length, breadth and height is given. Length is given as 1 meter. Breadth is given as 2 meter. Here you can see, and height is given as 1.5 meter. Now a girl named Ruxar is coloring this cabinet, painting this cabinet, and while she is painting, she is not painting the bottom of the cabinet. Means from the 6 faces she is painting only 5 faces. 5 faces, which 5 faces? 4 walls and the top part. This part and these 2, 3, 1 and 1 back. So 5 faces she is painting, that is 4 walls and 1 top. So let's first find the total surface area, and then length of cabinet L is given as 2 meter, breadth of cabinet B is given as 1 meter, and height of cabinet is given as 1.5 meter. Now total surface area of cabinet equal to, we will, as I have instructed, first we have to take only 5 faces, that is 4 walls and the top part. Now 4 walls area formula is twice BH into LH, and this top is length into breadth, and these 4 walls, that is twice BH plus LH. So we will add these 4 walls area with the top face area. So we get surface area of cabinet equal to twice BH plus HL plus LB. Inserting the values, we will get equal to 2 into 1 into 1.5 plus 1.5 into 2 plus 2 into 1. That is equal to 2. 1 into 1.5 is 1.5 into plus 1.5 into 2 is 3. So we get twice 1.5 plus 3 and 2 into 1 is 2. So we'll get 2 twice 1.5 plus 3 plus 2 meter square. Further solving will get equal to 2 into 4.5 plus 2 meter square, that is equal to 9 plus 2 meter square, that is equal to 11 meter square. Hence the surface area of the cabinet which Ruxar painted is 11 meter square. Next, question number 5. Daniel is painting the walls and ceiling of a cuboidal hall with length, breadth and height of 15 meter, 10 meter and 7 meter respectively. From each can of paint, 100 meter square of area is painted. How many cans of paint will she need to paint the room? Now it is said that one girl named Daniel is painting a cuboidal shaped hall in which she is painting the ceiling that is top face and the 4 walls of the hall, and the length, breadth and height are given of this hall. Now we have to find out that if for the painting these walls, if 100 meter square area can be painted from one can, means this much area, 100 meter square of area can be painted from one can of paint, then how many cans she will require to paint? So let's do the solution. Length of wall L is given as 15 meter, breadth of wall B is given as 10 meter and height of wall is H is given as 7 meter. Now as it is mentioned in the question that she is painting the ceiling and the 4 walls. So again we will write total surface area of hall equal to twice BH plus HL plus LB. Twice BH plus HL, this is the 4 walls area, and LB is the area of ceiling, that is the top face you can say. That is equal to, when let us insert the value, twice 10 into 7 plus 7 into 15 plus 15 into 10, that is equal to twice 70 plus 105 plus 150 meter square. Dear students, when we are solving this, don't make mistake in multiplying 2 by this is length into breadth is taken one time only, remaining 2 we are taking 2 times. So don't make mistake, 2 is multiplied only with this bracket, bigger bracket. We don't have to multiply 2 by this bracket. 15 into 10, this we don't have to multiply with 2. So we'll get 2 twice 70 plus 105 plus 150 meter square, that is equal to twice into 175 plus 150 meter square, that is equal to 350 plus 150 meter square, that is equal to 500 meter square. So the TSA of hall, excluding the bottom part, floor part of the hall, it is 500 meter square. Now it is given that one can is required to paint 100 meter square. So let's find out how many cans are required. Number of cans required for paint equal to area of hall upon area of one can, that is equal to 500 upon 100, that is equal to 5 cans. So 5 cans are required to paint the hall. Dear students, please copy all this in your regular CW with neat and clean handwriting. Thank you.